Okay, so I've just finished building my comparator and 555 timer circuit, which will provide the clock pulse for my stepper motor driver. Here are the two integrated circuits that I'm using. So the comparator is going to be the LM311 and the timer is next to it. The circuits for both are realized in this board. This is my threshold for the comparator and it's preset. I have preset it with the screwdriver, and this is a trim pot for controlling the signal that's outputted by the timer. And I have it connected here with a probe to the oscilloscope. I also got a multimeter there connected to the output of the comparator, which is going to be on this red wire, which has already fallen off. I just need to put it back in. There we go. And power supply, 5 volts over here, powering the whole board. And obviously we have the LDR here facing a very bright LED, white LED. So what will happen is the voltage at the output of the comparator will change when I interrupt the beam with an object like so. And to illustrate this, you can look at the comparator. So when the object is present, the voltage is 0 volts, and when I remove it, it will jump back to 5 volt. So this signal, instead of connecting it to the voltmeter for my system, it will actually be connected to one of the interrupt pins of my PIC, and that will cause an interrupt in my code, which will tell my system that an object has been detected and it's passed the beam. So if you imagine this is on a conveyor belt and the objects are moving, as soon as the object leaves, it will go back. So let's try with something smaller. So as the objects are passing through the sensor, voltage will drop. This is too transparent. Okay, we need something very solid. Okay, let's just do this. So when the object passes, voltage will drop. This will cause an interrupt in my system, and as soon as the object has passed the beam, the voltage will go back to 5 volt. And this is how the circuit will work in terms of detecting object. Now obviously this distance is not very practical between the two. Typically you would have this the sensor enclosed into a type of tube, and you would have a laser beam pointing to it, not an LED. But for this experiment, this is just a concept of how it would look like. You would have some kind of light source and a light sensor, and the change of intensity of that light will cause change in the voltage of the output of the comparator, and that's pretty much it. So for the timer circuit, I've calculated my resistor values and my capacitor values so that I'll get a signal which is particular frequency, which I've based on a stepper motor. So I've calculated what frequency I need, what minimum frequency I need to drive the clock pull source of that chip that's going to control a stepper motor. And based on those calculations, I've calculated the values of the resistors and capacitors for the 5.5 timer to achieve such a frequency. Currently, the signal is 330 Hertz. As you can see, that's the output. But I've calculated 320, so I need, because it's a trim pot, it's really difficult to adjust because it's really stiff, and any small change will actually affect the output very greatly. But you just need to remember that it's, when you calculate it, it's the minimum step change. So if it's greater than that, then it should be fine. If the signal is greater than what you calculated, it should be fine, as long as it's not too big of a difference. So I have like 14 Hertz above what I calculated, which would be pretty much fine. And you can see by the duty cycle, it's 60% of the time roughly 60% of the time the signal is in the high state, so it's gonna apply power 60% of the time, and then roughly 40% of the time it will be off. So yeah, that's my circuit for the input stage of the system, the conveyor belt system.